Let's look at some examples in section 4.2 on max and min values. They give us a function and we're supposed to find the critical numbers. And again, critical numbers are where the slope is 0, which could mean a max or min, right? The peak of a peak. You know, here the slope is 0 to peak, slope is 0 to trough. It could be in one of these kind of things. No, not like that. One of these kind of things where the slope is 0. They're just interesting points. Or where the slope is infinite. So like if it goes up asymptotically to something, the slope is infinite, which is basically when you have a dividing by 0. So you want to find all those interesting places where the slope is 0 or the slope is undefined, does not exist, which means infinite. Okay, so we got to take the derivative to find the slope. So the derivative here looks like a product rule. We could multiply this out, get 3 terms, multiply x to the 4/5 times each one of them, or just use a product rule. I think the product rule is easier. So derivative of the first, so that's 4/5 x, take away 1, negative 1/5 times the second, x minus 4 squared, plus the first one, x to the 4/5 times the derivative of x minus 4 squared, which is 2x minus 4 to the 1 times the derivative of the inside. Derivative of x is 1. I'll just write that to be clear. And we want to know when that is either 0 or infinite. So we'll set it equal to 0. And let's see if it's infinite anywhere. And turns out it is. X to the negative 1/5 is 1 over x, right? And that's 1 over x to the 1/5, which means it's on the bottom there, which means that if we plug in 0, x equals 0, we have a dividing by 0, which gives us infinity. So anytime you have an x in the denominator, which again, negative 1/5 means 1 over x to 1/5, we have an infinite. So right away we know that x equals 0 is a critical number. Slope isn't 0 there. It's, in a sense, it's undefined. Basically, something weird happens at x equals 0, so it's undefined. So that's one of our critical points. Okay, now we have an x minus 4 on both sides. So with x equals 4, we have 0 plus 0 equals 0, right? Plug in x equals 4, 4 minus 4 is 0, 4 minus 4 is 0. So x equals 4 is a critical number or critical point. Okay, so that's one of them. Now, let's see, let's divide both sides by x minus 4. We already took out x equals 4, so for x not equal to 4, then this is not 0. We're all looking at everything when x isn't equal to 4, so then we can divide by x minus 4, because we're not supposed to divide by 0. That gets rid of this one, and it makes that one, instead of a squared, it just takes away the squared, right? Take away this x minus 4, totally it's the 1, and we're left with 1x minus 4 here. Okay, now let's rewrite this. So we have 4/5 x to the negative 1/5 times x minus 4. I'm going to put this on the other side. So that's equal to negative x to the 4/5 times 2, because the x minus 4 went away. Okay, let's see. Let's multiply this out. X to the negative 1/5 times x. That's x to the 5/5 minus 1/5. So that's 4/5 x to the 4/5. Because 5/5 minus 1/5, you add exponents is 4/5. Yep, that's right. Minus, and then we have just 4/5 x to the negative 1/5 times 4, so that would be 16/5 x to the negative 1/5 equals, I can put the 2 first, negative 2 x to the 4/5. These fifths are a real pain. If we multiply everything by, let's see, to get rid of them, if we multiply this whole thing by x to the 1/5, that means, remember, we add exponents to be the same base. We have the same base, x, x, x. 1/5 plus 4/5 is 1. 1/5 times negative 1/5 is 0. That's x to the 0. That goes away. In other words, we have x to the 1/5 divided by x to the 1/5. They cancel. And x to the 1/5 times 4/5 is 1 again. So that way we get rid of all there's 1/5 things because they're just confusing. So I can multiply everything by x to the 1/5. So that would be 4/5 x minus 16/5, because that one goes away there, equals negative 2x, because again that just becomes a regular x. Well, this is looking a lot friendlier. Let's multiply everything by 5 to get rid of that 5 in the bottom, because that's confusing too. So now we have 4x minus 16 is equal to, multiply that by 5, negative 10x. Let's put the 10x over here. 4x, so it'd be plus 10x, so that'd be 14x is equal to, put the 16 over there, 16, or x is equal to 16 over 14, which is 7/4. Okay, so the last one, the last critical number is 7/4. So we have 4 critical numbers then. 2 from before, 0 and 4, and 7/4. So we have 0, put them in order, 7/4, and 4. Those are our critical numbers or points. And again, it's where the slope is 0, or the slope is undefined, which is the ones that make it 0 are x equals 0 and x equals 7/4, and the one where something weird happens when we're dividing by 0 is x equals 4. Okay, now we're done. And again, as always, you can graph this, throw this in on Desmos, and you can see what's happening at those places and check your work if you didn't know the answer. Now, in a test or something, you're not allowed to do that, but it's good practice to do when you're just working on homework. Use Desmos and kind of see if what you did is right and would it make sense, or if you forgot one. Okay, let's do number 33. 33 is a trigonometry one, which is really good practice, as we're going to see a lot more of these kind of things. So 2 cosine theta plus sine squared theta. Again, we want to find where the slope is 0 or undefined. So let's take the derivative. F prime of theta is, derivative of cosine is negative sine, so it would be negative 2 sine theta, plus sine, so our derivative of anything squared is 2 times it times the derivative of that thing, derivative of what's inside, which is sine. So that's just cosine. Derivative of sine is cosine. And we want to find out when that's 0. First off, we look, is it infinity? No, there's nothing weird about sines and cosines being infinity, so there's none of those weird ones. So we just want to know when it's 0. Okay, first, we can divide both sides by sine theta. Okay, or if sine theta is 0, then this is 0, and that's 0, and 0 times 0 is equal to 0. So the first solution is when sine theta is equal to 0. So when is sine theta equal to 0? Let's look at our unit circle. Sine is, let's put our axes in here. Sine is always the height. Okay, the y value is the sine in our unit circle. That means unit circle means this is 1, right? This radius of 1. So where is there no height? Well, there's no height right here at 0 degrees, or there's no height here at 180 degrees, which is also pi, right? 0, there's no height at 0 and at pi, or at 2 pi, or at 3 pi, or 4 pi, or at negative pi, or negative 2 pi. It goes on forever. So basically multiples of pi. So the way you'd write that is sinus theta at 0 when theta is equal to some multiple of pi. N is an integer, because it makes sense, right? Integer. So n, by definition, if you write that, everybody knows you mean that n is equal to ... negative 2, negative 1, 0, 1, 2, ... forever, so which means multiples of pi. So the answer for this one is theta is equal to n pi. Now, what if sine theta isn't 0? Now we can divide by sine theta to get rid of it. And then we have negative 2, divide this by sine theta, cancels out, plus 2 cosine theta is equal to 0. Let's put the negative 2 over here. 2 cosine theta is equal to negative 2. Of course, we can divide that by 2. Or cosine theta, oh wait, it's positive over there. Put the negative 2 over here, makes it positive. Or when cosine theta is equal to 1. That's the other place when this derivative is 0, where the slope is 0. Well, when is cosine theta equal to 1? Cosine is the x value in our unit circle. The x value is 1 right here. There's only one place right there, which means 0 or 2 pi or 4 pi or 6 pi or a negative, right? We could go here, we could go backwards, negative 2 pi, you end up in the same place. So theta then is 0 or 2 pi when it's 2n pi. We just multiply n by 2. So it would be 0. When n is 0, we get 0. When n is 1, we get 2 pi. When n equals 2, we get 4 pi. So multiples of 2 pi. So those are two places. We have multiples of pi and multiples of 2 pi. However, multiples of pi include this one. So really, all we need to do is this one. This is the most general answer. So the answer here, what are the critical numbers? There's an infinite number of them. They're just all the multiples of pi. And multiples of 2 pi, but again, multiples of pi are multiples of 2 pi. So that's the answer there. So, okay, hope that helps. Bye.